Have you ever wondered why some places have tall mountains while others have wide plains or deep valleys? Why do volcanoes erupt? Why do earthquakes happen? And how did these amazing landforms come into existence? The answer lies in the incredible forces that have been shaping our planet for billions of years. In today's video, we'll begin an exciting journey to understand landforms and their evolution, how Earth's surface is created, changed, and continuously reshaped. By the end of this lesson, you'll see our planet in a completely new way. What are landforms? Landforms are features on the Earth's surface that make up the terrain, such as mountains, valleys, plains, or plateaus. They also include coastal features, such as peninsulas or bays, and underwater features, such as ocean basins and mid-ocean ridges. Landforms are categorized by their physical attributes, such as elevation, orientation, slope, rock exposure, soil type. Some common examples of landforms are mountains, plateaus, plains, hills, valleys, deserts, river deltas, coastal cliffs. Think of the Earth as a giant sculpture. The different shapes on its surface are called landforms. Each landform has its own unique appearance and forms through natural processes that may take thousands or even millions of years. At first glance, the Earth may look calm and unchanging. Mountains appear solid, and plains seem permanent. But in reality, Earth's surface is always changing. These changes happen because powerful natural forces are constantly at work. Some forces come from inside the Earth. They build new landforms by moving enormous rock layers, creating mountains, triggering earthquakes, and causing volcanic eruptions. Other forces work on the Earth's surface. Wind, rivers, glaciers, sea waves, and even rain slowly wear down rocks, carry them from one place to another, and deposit them elsewhere. These changes usually happen very slowly. Most take thousands or millions of years, so we don't notice them during our lifetime. However, some events, such as earthquakes, volcanic eruptions, or landslides, can change the landscape within just a few minutes or hours. This continuous process of building, wearing away, transporting, and depositing materials is known as the evolution of landforms. Earth's surface is never completely still. Although the ground beneath our feet feels stable, it is never completely at rest. Deep below the surface, gigantic rock plates, called tectonic plates, are slowly moving. They move only a few centimeters each year, about as fast as your fingernails grow. But over millions of years, these small movements reshape entire continents. Even today, the Earth is constantly changing. New mountains continue to rise, coastlines shift, and islands are sometimes created by volcanic eruptions. So, our planet is a living, dynamic world, not a motionless one. The structure of the Earth. The Earth is made up of three main layers: crust, mantle, core. Each layer has different properties and plays an important role in shaping our planet. How do scientists know about these layers? No one has ever traveled to the center of the Earth. So, how do scientists know what is inside? They study seismic waves, vibrations produced by earthquakes. These waves travel through the Earth at different speeds. By observing how the waves move, scientists can determine the different layers and their properties. Why is the Earth's interior important? The Earth's crust and the upper part of the mantle together form a rigid layer called the lithosphere. This layer is broken into large pieces called tectonic plates. These plates slowly move over a softer layer of the mantle called the asthenosphere. The movement of these plates causes many natural events, such as earthquakes, volcanic eruptions, mountain formation. This is why the Earth's surface is always changing. The crust. The crust is the Earth's outermost and thinnest layer. This is the layer where we live. It contains all the continents, oceans, mountains, rivers, forests, and cities. Although the crust seems thick to us, it is actually very thin compared to the Earth's total size. Its thickness varies. Continental crust, about 35 to 50 kilometers thick. Oceanic crust, about 5 to 10 kilometers thick. The crust is made mainly of solid rocks and minerals. It is broken into several large pieces called tectonic plates, which slowly move over time. These movements are responsible for many major geological events, including earthquakes, volcanoes, and mountain formations. The mantle. Just beneath the crust lies the mantle, the thickest layer of the Earth. It extends to a depth of about 2,900 kilometers and makes up nearly 84% of Earth's total volume. The mantle is made of hot, dense rocks. Although these rocks are solid, they become soft enough under high temperature and pressure to flow very slowly over long periods. Inside the mantle, heat from the Earth's interior creates convection currents. These slow-moving currents act like a giant conveyor belt, pushing the tectonic plates above them. Most of the forces that create mountains, earthquakes, and volcanoes begin because of movement within the mantle. The outer core. Below the mantle lies the outer core. It is about 2,260 kilometers thick and is made mainly of molten iron and nickel. Unlike the solid mantle, the outer core is in a liquid state because of its extremely high temperature. As the molten metals move, they generate the Earth's magnetic field. This magnetic field acts like a protective shield, helping protect our planet from harmful charged particles coming from the sun. Without this magnetic field, life on Earth would be much more difficult. The inner core. At the very center of the Earth lies the inner core. Although temperatures here can reach about 5,400 to 6,000 degrees Celsius, which is similar to the surface of the Sun, the inner core remains solid. Why? Because the pressure at the Earth's center is so enormous that it prevents the iron and nickel from melting. The inner core is made mainly of iron with some nickel and is the hottest part of our planet. Landforms are specific physical features on the Earth's surface, such as mountains, valleys, and plains, that evolve through the continuous interplay of internal, tectonic, volcanic forces, and external agents, water, wind, ice, waves. Over time, these landscapes sequentially transition through three distinct stages of development: youth, maturity, and old age. This is just the beginning of Earth's incredible story. In Part 2, we'll explore how rivers, glaciers, wind, and sea waves continuously reshape these landforms over time. So don't miss it. If you enjoyed this lesson, like, share, and subscribe to Eduscope Planet for more simple, authentic, and easy-to-understand geography videos. See you in Part 2.